Hello, human geographers. We are back at it again. We've spent the last two lectures talking about maps and their purposes. Now, we're going to get into some other geographic tools, the data that they produce, and how we can use it to better understand our world. This first unit is what I like to call our toolbox unit. Really, this whole first unit is just adding tools to our toolbox, learning how to use them, because then we get to begin construction on the temple of human geography that we're going to build for the remainder of the year. So here's a list of geospatial technologies or tools that produce geospatial data. We're going to go over each of them in detail, providing real-life examples of how they can be used. And the reality is that geospatial data is used for a variety of reasons. There are personal reasons to use them, things like navigation with GPS, or analyzing schools in a particular area using a geographic information system. Many businesses use geospatial data through marketing, collecting data with polls and surveys, and then doing analysis of that data through layers in GIS. Governmental agencies will use remote sensing to evaluate how land is being used, or start a crowdsourced open mapping project to coordinate disaster relief. Really, the potential opportunities are limited only by your imagination. So let's take a look at them. We'll start with a tool that you're probably already familiar with, and that is Global Positioning System, or GPS. Global Positioning System is a system that determines the precise position of something on the Earth through a series of satellites, tracking stations, and receivers. And you probably caught those important words in that definition: precise position. This system uses 24 satellites that are in orbit, which transmit radio codes to a receiver via stationary tracking stations. The amount of time for that signal to reach your receiver, combined with the fact that it is simultaneously in contact with other satellites, finds your exact position on the Earth's surface. And you'll be able to contact at least 4 of those satellites at any time. This system allows us to determine an absolute location on the surface of the Earth by determining the latitude, longitude, and altitude of your position. And chances are you have a GPS receiver within arm's reach right now. That's your phone. And while most people are comfortable using GPS for navigation, we talked last lecture about how you can use it to establish point data that will be helpful in creating a dot distribution map. But now, let's ask a question that you may have some strong opinions about. Should parents track your location using the GPS technology on your phone? The New York Times wrote an article a few years ago examining some of the potential drawbacks and benefits of parents monitoring their children's location. I'd like you to jot down some of your opinions on that matter and bring those opinions to class as well, because I'd really like to hear them. GIS stands for Geographic Information System, which is a computer system that allows spatial data to be collected, recorded, stored, retrieved, organized, manipulated, analyzed, and displayed. Now, that definition reads like a laundry list of ways you could use GIS. And I'll be honest, I'm really biased towards this technology because there's a lot of really cool things that it can do. Now, there's a really important word that I want you guys to associate with GIS, and it doesn't show up in that definition. That word, if you hear it, you see it, they're probably talking about GIS. And that word is layers. All right? GIS layers data onto one another to allow us to examine relationships that exist in space. I'll give you a personal example. My very first experience with GIS was when I started teaching AP Human Geography. I went to a training, and the instructor got us all on to GIS software. We pulled up a layer of point data with the locations of all of the fast food restaurants within a particular census tract in Chicago. And then we layered on top of it data with incident rates of heart disease in that same census tract. We were looking for relationships. What do you think we saw? Within that census tract, the block groups, which is, again, a smaller unit of a census tract, within a census tract, the block groups with fewer fast food restaurants had lower rates of heart disease and fewer heart attacks. And the areas that had more fast food restaurants had more medical issues associated with heart disease. And the link here looks at a variety of characteristics also associated with heart disease and stroke. But that's not all. You have the ability to sort this data by time period, by age, gender, and race or ethnicity. Then you also have the ability to adjust the scale of analysis between the subnational or state scale and the county scale. There really are a tremendous amount of ways that you could use GIS. So let's look at a few. If you wanted to map the distribution of a particular store and then identify potential locations for future expansion, GIS would allow you to do that. This image comes from an activity that we're going to do later in the year where you're going to have to do exactly that. You're going to have to try and figure out where should businesses open up given certain characteristics. But what happens if your business has a certain clientele? For my master's, I published an article that detailed the ideal location for a clothing store for young adults with an upper middle class economic background and applied it to the Las Vegas Valley. I was able to find areas that were ideal for a new American Eagle store, that's what I was looking at, as well as areas where there weren't enough of the target demographic, younger people, that have some money to go to American Eagle and buy clothes or whatever. I think there were areas that could support that and areas that couldn't. And there were areas where there was overlap with existing stores. And this was a lot of fun to work on. GIS can also be helpful in how governments decide how land is going to be used. What you see here is a GIS program from the city of Henderson. During this year, we're going to talk about industry and business. We're going to talk about cities. And we're going to talk about something called zoning laws. Zoning laws are restrictions on where certain types of activities are allowed to take place within a city. So notice the zoning laws for the area surrounding Coronado. There's Coronado in the green. Most of the areas surrounding Coronado are zoned for residential purposes, houses where people live. But notice there are differences in terms of how densely populated each area is. Most of the areas around Coronado are what we call medium density residential areas, meaning that they have anywhere from 6 dwelling units per acre. That's the metric that the city of Henderson uses. And 6 dwelling units would usually be like single family homes, all the way up to 16 dwelling units per area. And those areas are usually apartments. And so urban areas tend to be more dense and more concentrated. But this map shows us that not every residential area has the same density. And while most of this image is residential, other areas can be devoted to economic uses, others for political or public uses. There are spaces that will be social or perhaps cultural uses. And then there's a term that we'll see called mixed use, meaning that it crosses over several of these categories. You'll have businesses and apartments above them. That's mixed use. And these areas can even be further subdivided. Areas that are denoted for economic activities could include offices for financial services. They could be retail stores. They could be warehouses. They could be factories. And all of these are going to be located in different areas depending on the activity that's taking place. This GIS platform allows us to see that and investigate that. And if you're thinking that this is getting a little too real, there's some fun ways that people can use GIS technology. There's a professor of anthropology that came up with a lesson on disease transmission by looking at the likelihood of a zombie apocalypse affecting his local area. And this image shows what we call a buffer analysis to show the potential for zombie movement where he lives. Like I said, there's a lot of ways to use GIS technology. Remote sensing is the last of the big three geospatial tools. And this is the acquisition of data about Earth's surface from a satellite orbiting the planet or from other long-distance methods. And that's the key. They're acquiring this data from far away from the Earth, so we can see a lot more of the Earth and about the Earth. And there's a wide variety of tools that fall under the umbrella of remote sensing. I mean, technically, Google Earth is part of remote sensing, but I don't think the AP exam is going to ask you about Google Earth. Other parts of remote sensing include things like aerial photography, thermal infrared scanning, microwave mapping. And the neat thing about these different methods of remote sensing is what you're able to see here. These satellites can acquire data outside the visible portion of the electromagnetic spectrum. In fact, in the link below, it references a type of remote sensing technology called LiDAR, which stands for Light Detection and Ranging, which was able to discover over 60,000 Mayan ruins by essentially looking through the jungle canopy. They saw through the trees to see what was underneath. And while it can do all that, the College Board has shown a little bit of a tendency to focus on analysis of aerial photographs. So let's get some practice with that. This is a photograph of the boundary between Haiti and the Dominican Republic. Haiti is on the left, the DR is on the right. Let me ask, do you think that these two countries have different policies about resource consumption, about agriculture, about deforestation? They certainly do, and we're going to talk about that later this year. But for now, we want to understand that a simple photograph from the sky would be able to provide us a wealth of information if we look closely and think critically. Two major topics that we discovered this year is how land is used in different areas, in rural areas, in urban areas. By looking at this aerial photograph, can you tell which one is which? Now remember, we mentioned earlier that urban areas tend to be more dense, concentrated. We can see that on the right side of this photograph. And rural areas, on the left, tend to be less dense and more dispersed or spread out. Now, this slide is a good review of the big three geospatial technologies. That is GPS, GIS, and remote sensing. Now, take a moment, press pause on the video, take a look at those different bullet points, and I want you to add to each of those columns. What can you add to each of those? Go ahead and put those in your notes. With the expansion of communication technology, online mapping has really emerged as an interesting topic of conversation. And we're going to talk about the benefits of online mapping in just a moment, but I want to add a cautionary note as well. We've already seen that we need to be critical of maps, even from well-intentioned and experienced cartographers. But it is easier than ever to produce maps with the internet, and bad maps can disseminate quickly through social media and other communication platforms. Essentially, anyone with a computer and the internet can be an amateur cartographer, and we don't know what their intentions are or where their data is coming from. So we have to remain critical of sources of information, including maps. All right, I'll stop being a Debbie Downer. Online mapping has some pretty interesting opportunities, far more than I would be able to talk about here. But there are a few cool ones that I do want to highlight. Google Tour Builder allows us to build and create maps and stories for a variety of purposes, depending on the story that needs to be told. Probably my favorite online mapping platform is OpenStreetMap, which is a crowdsourced map of the world and many of the activities and features in it. And there's some interesting and really awesome offshoots from the OpenStreetMap team. There is the humanitarian OpenStreetMap, which, as the name implies, is leveraging crowdsourced mapping activities for humanitarian causes, like responding to natural disasters and outbreaks of disease. Youth mappers bring students into the realm of online mapping using topics that students are passionate about, like protecting the rainforests is an example that they have. Finally, missing maps seek to create maps for areas that have not been mapped before. Now, you might be thinking, wait, it's the 21st century. How are there areas that haven't been mapped yet? Well, our world is dynamic and constantly changing. One of the activities I participated in with OpenStreetMaps was mapping a refugee settlement that had started up in a border area of Venezuela. I was sitting on a laptop in Cincinnati, Ohio, mapping areas that I had never been to and didn't exist the month before, using new aerial photography and a crowdsourced mapping platform. Now we're getting into some of the other tools that geographers will use. Next up are polls and surveys. These are tools that collect quantitative data, meaning that it can be measured with numbers. Quantitative, quantity, numbers. Polls and surveys need a lot of participants in order to make this quantitative data reliable and useful. And an example of a really reliable source of quantitative data is the US Census. A census is the complete enumeration or count of a population. And the US Census collects data, particularly about the number of residents and their respective ages, every 10 years since 1790. But beyond the once a decade count, the US Census Bureau, along with other polling services, will look at other types of quantitative data. This includes demographics like sex, you can see the count of males, females, economics like median household income or poverty rate, as well as elements of culture, how many people speak a certain language, practice a certain religion, or identify with a certain race or ethnic group. Even the analysis of age only begins with the counting of each cohort, meaning how many 10 to 14-year-olds live in the US. Once they have that quantitative data, they can create what we call a population pyramid. And this is the population pyramid of the United States. Then we can begin to analyze the number of people, say, who are too young for work, usually 14 or younger, and the number of people who are too old to work, like 65 and older. And then compare those numbers with the potential working age population aging between 15 and 64. And that gives us an idea of how many people need support and how many people there are to support them. And we'll call that the dependency ratio. More on that later. All of these figures fall into the realm of quantitative data. Field observations, on the other hand, are often described as qualitative data. That means that the quality of the work is far more important than the quantity. I once had someone describe qualitative data as data that you collect with your 5 senses. You see the agricultural processes in action. You smell the poor sanitation system. You speak with the refugee fleeing their home and hear their description of their experience. Qualitative data is harder to analyze, though, than quantitative data, because people's perceptions, opinions, and reasons influence the quality of that work. But those perceptions, opinions, and reasons for doing things are an important part of human geography. So qualitative data contributes greatly to our geographic understanding of places and the processes surrounding them. Now, to be fair, polls and surveys can fall into the category of fieldwork because you're out in the field collecting the data. It's just a quantitative form of fieldwork rather than qualitative. And the reality is that much of the data used by geospatial technology is initially collected through fieldwork. Fieldwork is where most geographic inquiry begins. A geographer is out in the field and they notice something, and then they start asking questions. That's why the 5 senses rule is a really good one to describe qualitative information. And I want to end this slide by asking a big question. What can you learn about a location from field observations that you can't learn from a GIS map? A famous geographer posed a similar question when lamenting the changes to geography programs around the country. He noticed that future geographers were spending more time behind a computer screen and less time out in the field. Now, this might just be the geography equivalent of get off my lawn guy, but it's an interesting question all the same. So in your notes, what could you learn in the field that you wouldn't be able to learn from a GIS map or an aerial photograph? And to continue on that same train of thought, what are we able to learn from quantitative evidence compared to qualitative evidence? We've got 2 examples here, both from India. What can you decipher about India that's different between quantitative and qualitative? The reality is that you'll need to analyze both. You'll need to analyze maps and photographs this year. You'll have to decipher graphs as well as firsthand personal accounts. You'll interpret population pyramids and examine specific case studies. From there, we'll be able to contextualize them through our understanding of the world and the processes occurring throughout it. We finish our discussion of the first theme of geography with a short explanation that differentiates absolute and relative location. Absolute location is the precise spot where something is. We often use a system of meridians and parallels to describe the absolute location of a place or feature. We call that system latitude and longitude. Now, I'm sure you're already familiar with this system, but let's just cover the basics. Longitude are the lines, called meridians, that run the long ways connecting the North and South Poles. And while they connect the North and South Poles, they actually measure east and west of the prime meridian, which is found at 0 degrees longitude. And roughly on the other side of the world, running through the Pacific Ocean, is the international dateline, which generally follows 180 degrees of longitude. Latitude, on the other hand, are the circles, called parallels, that are parallel to the equator, which is found at 0 degrees latitude and divides the world into the northern and southern hemispheres. I always remembered latitude because the parallels look like rungs on a ladder. Get it? Latitude, ladder. Anyway, each degree of latitude and longitude can be subdivided into 60 minutes, and each minute has 60 seconds, which is simply a way to be more precise with our location. So, for example, using this system, we can give the absolute location of any place on the Earth's surface. Our example, the latitude and longitude for Las Vegas is 36 degrees, 10 minutes, 30 seconds north by 115 degrees, 8 minutes, 11 seconds west. In addition, the hemispheres have a positive-negative designation, which is similar to a coordinate plane in a math class. The eastern and northern hemispheres have a positive designation, while the western and southern hemispheres have a negative designation. Using this positive-negative system to identify the absolute location of Las Vegas, it would be positive 36 degrees, 10 minutes, 30 seconds by negative 115 degrees, 8 minutes, 11 seconds. And this system happens at the global scale. But there's also systems that occur at more regional scales. In the United States, the Public Land Survey System, created by the Land Ordinance Act of 1785, used a system to designate areas, particularly in what we now call the Midwest. The term township was used to designate areas north or south of a baseline, while ranges measured east or west of a principal meridian. And that's why this is often called the township and range system. It's probably how you're more likely to hear it. And we'll talk more about that as the year goes on. If you've ever heard someone say, location, 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 chances are they weren't talking about absolute location, but rather relative location. And that's where we'll finish up tonight. Relative location describes where something is in relation to other things. I used it commonly when I was a kid, before smartphones, to give directions. I would tell a new friend that to get to my house, you had to head over the train tracks, and when you hit McDonald's, turn right. And then it's the third house on the right. That's relative location. And to differentiate the two, could you find my childhood home based on the directions I just gave you? Probably not, because we don't know which train tracks or McDonald's I'm talking about. But if I give you the absolute location, if I gave you the latitude and longitude of my childhood home down to the minute and second, do you think you'd be able to find it? Probably in a matter of seconds, given the technology that we have now. But let's go back to that location, location, location example. Realtors will often say this because it's all about where a house or business is in relation to the things around it. The things around it affect property values far more than latitude and longitude do. So connectivity and accessibility are often included in discussions of relative location because they affect how important or desirable a particular location will be. Connectivity deals with how well locations are tied together. So we could ask questions like, are there roads, railways, or other modes of transportation that connect them? What kind of communication infrastructure is in place there? Do they have telephones, cell phone towers, internet? Is it radio or TV? What are we talking about? How strong is their system of pipelines and sewers? And then when we talk about accessibility, it deals with time and ease, which are related to how connected a location is. So as distance increases, time and money become bigger and bigger factors. We call that the friction of distance. So accessibility asks, how easy or difficult is it to overcome the friction of distance? And when a location has strong answers to those questions of connectivity and accessibility, well, that location is looking pretty good. That's where we'll end tonight. Have a wonderful evening, and I'll see you back in class.